Diagram shows the types of regression. First, linear regressions. Linear regression is a statistical regression method which is used for predictive analysis. It is one of the very simple and easy algorithms which works on regression and show the relationship between the continuous variables. It is used for solving the regression problem in machine learning. Linear regression shows the linear relationship between the independent variable x and the dependent variable y. Hence, it's called as linear regressions. If there is only one input variable x, then such linear regression is called simple linear regression. And if there is more than one input variable, then it is called multiple linear regressions. The relationship between the variables in the linear regression model can be explained using the below diagram. So here in this diagram, the experience is marked in the x-axis and the salary is marked in the y-axis. If the experience increases, the salary also increases. That is called linear regressions. Some popular applications of linear regressions are analyzing trends and sales estimates, salary forecasting, real estate predictions, arriving at ETAs in traffic. Next, types of linear regressions. Linear regressions can be further divided into two types. That is called simple linear regressions, multiple linear regressions. Already I said if a single independent variable is used to predict the value of a numerical dependent variable, then such linear regression algorithm is called simple linear regressions. If more than one independent variable is used to predict the value of a numerical dependent variable, then such linear regression algorithm is called as multiple linear regressions. Linear regression line. Here one line is called linear regression line, that is called a positive line of regressions. If the dependent variable increases on the y-axis and the independent variable increases on the x-axis, then such relationship is termed as positive linear relationship. That is, the positive relationship means the x is also increasing as well as y is also increasing. This is called negative linear regressions. In negative linear increases, if the x is increasing, the y is decreasing. That is called negative linear regressions. Simple linear regression in machine learning. Simple linear regression is a type of regression algorithm that models the relationship between the dependent variable and a single dependent variable. The key point in a simple linear regression is the dependent variable must be continuous or real value. Real value means they are continuously changing the value. However, the independent variable can be measured on continuous or categorical values. Simple linear regression algorithm has mainly two objectives: model the relationship between the two variables, such as the relationship between income and expenditure, experience and salary, etc. Forecasting a new observation, such as weather forecasting according to the temperature, revenue, and the revenue of a company according to the investments in the year, etc. So these are the two objectives of simple linear regressions. Simple linear regression model. So it gives the equations for the simple linear regression model is y is equal to a0 plus a1 x plus sigma, where a naught is the intercept of the regression line, a1 is the slope of the regression line, which tells whether the line is increasing or decreasing. Sigma is equal to the error term. Linear regression learning model. Learning a linear regression model means estimating the value of the coefficients used in the representation with the data that we have available. So in this section, we will have a brief look on the four techniques to prepare a linear regression model. First one is simple linear regressions. Already we have discussed the simple linear regression. The second one is ordinary least squares method. When we have more than one input, we can use ordinary least squares method. The ordinary least square method seeks to minimize the sum of the squared residuals. This means that given a regression line, through the data, we calculate the distance from each data point to the regression line, square it, and the sum of all the squared errors together. This is the quantity that the ordinary least square seeks to minimize. This approach treats the data as a matrix and uses linear algebra operations to estimate the optimal value for the coefficients. It means that all of the data must be available and you must have enough memory to fit the data and perform matrix operations. The third method is a gradient descent method. When there are one or more inputs, you can use a process of optimizing the values of the coefficients by iteratively minimizing the error of the model on your training data. This operation is called gradient descent and works by starting with random values for each coefficient. The sum of the squared errors are calculated for each pair of input and output values. A learning rate is used as a scale factor, and the coefficients are updated in the directions towards minimizing the error. The process is repeated until a minimum sum squared error is achieved or no further improvement is possible. When using this method, you must select a learning rate parameters that determines the size of the improvement step to taken on each iteration of the procedure. Gradient descent is often taught using a linear regression model because it is relatively straightforward to understand. The last one is a regularizations. There are extensions of the training of the linear model called regularization methods. These seeks to both minimize the sum of the squared error of the model on the training data, but also to reduce the complexity of the model. Two popular examples of regularization procedures of linear regressions are lasso regression and the ridge regressions. In lasso regressions, where ordinary least square is modified to also minimize the absolute sum of the coefficients, where ordinary least square is modified to also minimize the squared absolute sum of the coefficients. Preparing data for linear regressions. So there are some of the methods for preparing data for the linear regressions. One is linear assumptions, remove noise, remove collinearity, Gaussian distributions, and the risk scale inputs. The next heading is here multivariant regressions. Multivariant regression is a supervised algorithm, machine learning algorithm involving multiple data variables for analysis. Multivariant regression tries to find out a formula that can explain how factors in variables respond simultaneously to change in others. There are number of areas where multivariant regressions can be used. That is, some of the examples are Pranti wants to estimate the price of a house. She will collect details such as the locations of the house, number of bedrooms, size in square feet, amenities available or not. Basis these details, price of the house can be predicted and how each variables are interrelated. An agriculture scientist wants to predict the total crop yield expected for the summer. He collected some of the details related to the yield. If an organization wants to know how much it has to pay to a new hire, they it will into account many details such as education level, number of experience, job locations, skills, etc. Economists can use multivariate regressions to predict the GDP growth of a state or a country based on parameters like total amount spent by consumers, important expenditure, total gains from exports, total savings, etc. A company wants to predict the electricity bill of the apartment. The details needed here are the number of flats, the number of appliances in usage, the number of people at home, etc. With the help of these variables, the electricity bill can be predicted. So mathematical equations of multiple regressions. The simple regression linear model represents a straight line, meaning y is a function of x. Y is equal to m1 dot x plus m2 dot z plus c. Y is the dependent variable, that is the variable that needs to be predicted. X is the first dependent variable, it is the first input. Y1 is the slope of x1. Let us know the angle of the line. Z is the second independent variable, it is the second input. M2 is the slope of the Z, it helps us to know the angle of the line. So the equation of a model with two input variables can be written as y is equal to beta 0 plus beta 1 dot x1 plus beta 2 dot x2. The equation for a model with three input variables can be written as y is equal to beta 0 plus beta 1 dot x1 plus beta 2 dot x2 plus beta 3 dot x3. What is cost to functions? The cost to function is a function that allows a cost to samples when the model differs from observed value. So the cost is the sum of the squared errors. Example, 1 by 2m sigma of h theta of x power I minus y power I power of 2. So steps of multivariate regressions analysis. That is, first one is a feature selections, normalizing features, select loss functions and hypothesis, set hypothesis parameters, minimize the loss functions, test the hypothesis functions. Advantages of multivariate regressions. The most important advantages of multivariate regression is it helps us to understand the relationships among variables present in the data set. This will further help in understanding the correlations between dependent and independent variables. Some of the disadvantages of multivariate regressions are multivariate techniques are a bit complex and require a high level of mathematical calculations. The multivariate regressions model output is not easy to interpret sometimes because it has some laws